Hey everyone, and welcome. Today we're going to unravel a little bit of everyday magic, something we all do without a second thought, printing a document. But have you ever actually stopped to wonder how your computer singles out your printer from all the other gadgets on your network? Well, the answer gets to the very heart of how our local devices talk to each other. Okay, let's just jump right in. Think about your home network right now. You've probably got phones, laptops, a smart TV, maybe a gaming console, all sharing the same Wi-Fi. You click print, and somehow that file zips straight to the printer and doesn't end up on your roommate's screen. How does your network pull that off so perfectly, every single time?
So this whole challenge has a name. In the networking world, they call it the local delivery problem. And it's exactly what it sounds like. How do you get one piece of information to one specific device when there are dozens of others all connected to the same wire or Wi-Fi signal? It's kind of like trying to deliver a pizza to a single apartment in a massive building with hundreds of identical doors.
Luckily, our networks have a brilliant solution. It's a set of rules that acts like a super fast, incredibly efficient local mailman. The technical term for this system is the data link layer, but you'll almost always hear it called Layer 2. And this is where all the local neighborhood action happens.
Right, so Layer 2's entire world is just your local network. It couldn't care less about Google servers or what's happening on the internet. Its one and only mission in life is to make sure data gets from your computer to your printer or from your phone to your TV reliably and without any mistakes. And here's how it does its job. It takes your data and neatly packages it into something called a frame. Then it stamps that frame with a very specific physical address so it knows where to go. Its whole job is then to deliver that frame just within the local network. Oh, and it's also got this neat built-in error checking to make sure the delivery wasn't corrupted along the way. All of this happens before your data even thinks about going out to the wider internet.
You know, for any delivery system to work, you really only need two fundamental things, right? You need something to put the message in, an envelope, and you need a reliable address to write on it. Well, it turns out Layer 2 works the exact same way.
So that digital envelope we just mentioned, that's called a frame. It's basically a digital container that takes your actual data, like the words and images in your document, and wraps it up with all the necessary local delivery information, including, most importantly, a to address and a from address.
And this is the address that gets stamped on that envelope. A MAC address, which stands for Media Access Control Address, is a totally unique identifier that's physically burned into your device's network hardware by the manufacturer. It's like a permanent serial number for your network card that can't be changed.
And this is what makes it so powerful. It's this 48-bit number, written in this kind of funny-looking hexadecimal format. But here's the kicker. It's unique worldwide. No other device on Earth has the same MAC address as your laptop. And because it's physically part of the hardware, it doesn't matter where you go. Take your laptop to a coffee shop, a library, an airport. That MAC address stays with it for life. It's its permanent identity.
Okay, so we've got our data in an envelope and it's stamped with a permanent physical address. Now what? Well, it heads off to the network's local sorting office, and that job is handled by a piece of hardware called a network switch.
If you have a regular home router, it almost certainly has a switch built right in. You know those few Ethernet ports on the back? That's the switch, and its job is to be an intelligent traffic cop. It doesn't just blindly send data everywhere. It actually reads the destination MAC address on every single frame and makes sure to forward it only to the port that leads to the correct device.
So how does it know where everything is? This is the really clever part. It learns on the fly. Whenever your computer sends out data, the switch looks at the from address on the frame and says, aha, so that MAC address is coming from port 4. Got it. It then builds a little internal map, a MAC address table, that links every device's MAC address to the physical port it's plugged into. It's constantly building and updating this map of the neighborhood. Okay, but this brings up a great question. What happens if your computer wants to send something to a brand new printer you just plugged in? The switch has never seen that printer's MAC address before, so its internal map is blank for that destination. What does it do then?
It does the only logical thing it can do. It shouts. The switch makes a copy of the frame and sends it out to every single device connected to it, essentially yelling, "Hey, is this for you?" Now, your phone ignores it, your laptop ignores it, but the new printer sees its own MAC address on the frame and replies, "Yep, that's me." And bam. The moment the printer replies, the switch learns its location, adds it to the map, and never has to shout for it again.
So this shouting is actually a formal process called a broadcast. There's even a special MAC address, all Fs, that every device understands means this message is for everybody. It's absolutely crucial for how devices discover each other.
But as you can imagine, you don't want too much shouting on the network or things get noisy and slow. So switches try to keep broadcasting to a minimum.
Okay, so we've totally mastered local delivery. Your computer can find your printer, no problem. But most of what we do isn't local, right? We're trying to watch a video from a server on the other side of the world. That data needs to leave the neighborhood.
And this slide right here is one of the most important concepts in all of networking. Your MAC address, the layer 2 address, is like your permanent house number. It's only useful for the local mailman. Your IP address, on the other hand, is a layer 3 address. Think of it like your postal code. It's temporary. It can change every time you connect to a new network. And its job is to tell the global postal service which city or which network you're currently in. You need both to get anything done.
So when the switch sees a frame addressed to somewhere out on the internet, it knows that's beyond its pay grade. It's a local mailman, not a long-haul trucker. So it sends that frame to the one device that can talk to the outside world, the default gateway, which is your router. The router then basically rips open that local layer 2 envelope and puts the data inside a new package ready for its long journey across the internet using layer 3. So we have gone pretty deep into frames, MACs, and switches. You might be thinking, okay, this is interesting, but why does this really matter to me?
Well, it matters because this is where most of your everyday network headaches happen. Seriously, when your laptop can't find the printer or your Wi-Fi is acting weird, 9 times out of 10, the problem is right here at layer 2. Understanding how this local delivery system works is like a secret weapon for troubleshooting your own network problems. And this quote just sums it all up perfectly. Everything we do online, from sending an email to streaming a movie, absolutely depends on this first fundamental step. If you can't get the local delivery right, nothing else in the huge world of networking can even begin to happen.
And that leaves us with the perfect question to end on. We know our switch is the expert at delivering mail within our own town, but who is the nationwide postal service? Who's the one figuring out the best route to get a package from one coast to the other, navigating thousands of different cities and highways along the way? Well, that is the job of Layer 3, and that is exactly where we're headed next time. Thanks for joining me.